All right. Now, to do this differentiation, you have to rewrite it as 5x squared minus 4, and you have to raise it to the half power. All right, so you can use chain rule or composite rule, whichever word you want to call it. Now you can find dy by dx by saying dy by dx is equal to carry down the power. So you bring down the half, subtract 1 from the power. So you write 5x squared minus 4. And you raise it to the minus half. And then you multiply it by the differential inside the bracket. The derivative of 5x squared is 10x. And that's that. So now you can actually find what is dy by dx. dy by dx is equal to, now, a half of this times 10x. Well, a half times 10x is 5x. And then right here, 5x squared minus 4 to the negative half. That can go in the denominator as the square root of 5x squared minus 4. So that is dy by dx. dy by dx is 5x over the square root of 5x squared minus 4. Nice and easy. Soft. The next part of the question, says the point P, which is 1,8, lies on the curve with equation 2x times x plus 1 all squared. And it says determine the equation of the normal to the curve at the point P. So the point P, which is 1,8, lies on the curve with equation this. Determine the equation of the normal to the curve at P. So first thing, to find the equation of the normal, we need to find dy by dx. Now dy by dx is going to be equal to this curve right here. To find dy by dx, I'm going to have to use product rule. Keep the first times the derivative of the second. And the derivative of the second is 2 times x plus 1. Keep the first, then differentiate the second, plus keep the second and differentiate the first. Differentiating the first, I get 2 times x plus 1 all squared. All right, so that's dy by dx. Now I need the gradient when at P. All right, now the gradient at P is going to give me the gradient of the tangent at P. So at P, we know that x is equal to 1. At P, the gradient of the tangent is going to be equal to, I plug in x as 1 to get 2 times, when x is 1, this becomes 2 times, x is 1, I get 1 plus 1 is 2, 2 times 2 is 4, so I get 2 times 4, plus 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8. So this works out to be 2 times 4, 8, plus 8, which is 16. All right, so that's 16. So that's the gradient of the tangent. If the gradient of the tangent is 16, then that is telling me that the gradient of the normal is going to be negative 1 over 16. So that's now the gradient of the normal. So then what's the equation of the normal? The equation of the normal at P is then y minus the y value at P, which is y minus 8. That's equal to the gradient of the normal, which is minus 1 over 16, times x minus the x value at P, which is x minus 1. That's the equation of the normal at P. Nice and easy. Now this part of the question says, obtain the equation for each of the two tangents drawn to the curve at the points where y is equal to 16. What? Obtain the equation of each of the two, obtain the equation of each of the two tangents drawn to the curve y equal x squared at the points where y is 16. Okay, I understand now. So, didn't like the wording at first, but if you think about the curve y equal x squared, I'm just going to give you a rough sketch. If you think about the curve y equal x squared, it looks something like this. This is x and y axis. This is it. All right, this is the x-axis is the line y equals 0. All right, this is y equal x squared. When y is 16, y is 16. When y is 16, where is 16? This is the line y equals 0. So y equals 16 is, the line y equals 16 is somewhere here. I'm just showing you, this is a rough sketch. This is the line where y equals 16. They want the two tangents. The two tangents is for the curve. So this is one point on the curve. When y is 16, then x is going to be 4. This is when x is 4. And when y is 16, x is also negative 4. So what they're asking us to find, so this is just graphically, what they're asking us to find is the equation of this line, that's a tangent at that point, and the equation of this line, which is another tangent at this point. So that's what they're asking us to do to find these two equations. So it says obtain equation for each of the two tangents to the curve where y is 16. So they're asking us to find the equation of these two black lines. So come let us do that. It says obtain each of them. So first thing you can tell them that when y is equal to 16, you're gonna get that x is equal to plus or minus 4. Clearly. And so if y is equal to x squared, and let's find dy by dx, then dy by dx is going to be equal to 2x. That's dy by dx. dy by dx is 2x. All right, so let's find the equation of the first tangent. So I'm going to call it first tangent. All right, so first tangent means t. Now, first thing I need is the gradient of the first tangent. So I'm going to call it m1. The gradient is when x is negative 4, the gradient is minus 8. So the equation of the first tangent is going to be y minus the y value of 16, and that's equal to the gradient of the tangent, negative 8 times x minus x1. x1 in this case is x minus 4, so it's x minus minus 4 is x plus 4. So that's the first tangent. Now I'm going to write second tangent. Second t means the equation of the second tangent. The equation of the second tangent is going to be y minus 16 is equal to the gradient of the second tangent, which is positive 8. How do I know it is positive 8? When x is 4, he's going to give us the next gradient. When x is 4, 2 times 4 is 8. 2 times 4 is 8. And so the equation of this is now y minus 16 into x minus 4. Nice and easy. So as you can see, this is the equation of the first tangent. This is the first one. This is the equation of the first tangent. That's for this black line right here. And this one is for the equation of the second tangent, which is this black line right here. All right, you can go ahead and put it in standard form, but it did not ask me to do that. So I am finished right there. Soft. This takes care of question 5. Question 6. Question 6 want me to work out the indefinite integral of 3 cos theta minus 5 sin theta d theta. And so to work out this integral of 3 cos theta minus 5 sin theta d theta, to work this out, we're going to get the integral of 3 cos theta minus 5 sin theta. When I integrate cos, let me not put by the integration sign, I'm just going to do it. When you integrate cos, you get sine. So this becomes 3 sine theta. Then when you integrate sine, you get minus cos. So you get minus become plus. So you get 3 sine theta plus 5 cos theta. But then when you integrate, you add a constant of integration. So you put plus k. Imagine they give you 3 marks for that. Nice and easy. Soft. Let's go ahead and continue. So now we're here, we're evaluating the integral from 1 to 3 of 2 over x squared minus 3 plus 2x cubed dx. So let's do this integration. So if we're integrating this now, right? We're doing this integration. The integration of this is going to be equal to, first thing I want to rewrite this. Don't look at it as 2 over x squared, please. I want you to look at 2 over x squared as 2x to the negative 2. So when you're integrating it, you can know that when you integrate that, it becomes 2x to the minus 1, add 1 to the power, and divide by the power, minus, add 1 to the power, so it becomes 3x, plus 2x cubed, you add 1 to the power to get 2x to the 4, divide by the power of 4. And you're integrating this from 1 to 3. So what does that give us? That's equal to, plug in when x is 3. Plug in when x is 3 first, you're going to get, when x is 3, we're getting 2 times minus 2 over x is 3 minus 2 over 3 minus 3 times 3 is 9 plus, plug in 3 here, 2 over 4 is really a half, so it's really a half of 3 to the 4th power. So that's what you get when you plug in 3, and then you're going to subtract when you plug in 1. When you plug in 1, you're getting 1 to the minus 1 is 1, 2 over minus 1, that's minus 2. Plug in 1, you get minus 3. Plug in 1, you get plus a half. So now we'll put all of this in our calculator and see what we get. So let's work out this part first. Minus 2 over 3 minus 9 plus a half of 3 raised to the 4th power. And I am getting 30.83. I generally don't like to write decimals, but in this case it seems easier. 30 and 5 over 6 minus negative 2 minus 3 plus a half. That's minus 4.5. So it's minus negative 4.5, so it becomes plus 4.5. So what we get is the integral of that works out to be 30 and 5 over 6 plus 4.5 I get 35 and 1 over 3. I get 106 over 3. Nice and easy. Soft. All right, let's look at part B. Part B says the following figure shows a finite region on the curve, and the curve is y is equal to x minus 2 all squared plus 5. So they give us a curve and they complete the square. What I'm going to do is I'm going to expand out this. I'm going to put it in regular form, in standard quadratic form. This would be x squared minus 4x plus 4 plus 5. And you might ask me, so sir, why did you do that? If I put the curve in regular quadratic form, or what's known as standard quadratic form, it makes it easier for me to integrate. So y is equal to x squared minus 4x plus 9. This looks easier to integrate. Now, let's say on the area under the curve. The area under the curve is going to be equal to the integral from 1 to 2. So integrating from 1 to 2 of the curve, which is x squared minus 4x plus 9. That's what we're doing, x squared minus 4x plus 9. Nice and easy, soft. So this is what we're doing. We're finding this area. So when we integrate this, what do? We add 1 to the power, get x cubed, divide by the power, minus 4x, add 1 to the power to get 4x squared, divide by the power of 2, plus 9x. And we're integrating from 1 to 2. Integrating from 1 to 2. So let's go ahead and knock ourselves out. Let's go ahead and knock ourselves out with this nice question. Plug in 2 first. Plugging in 2, we get 2 cubed, which is 8, which is 8 over 3, minus, plugging in 2, we get 2 squared, which is 4. 4 times 4 is 16. 16 over 2 is 8. So that's minus 8, plus 2 times 9 is 18. And then we subtract, plugging in 1. When you plug in 1, you're going to get 1 cubed over 3, which is 1 over 3, minus plugging in 1, minus 4 over 2, which is 2, plus plugging in 1, we get 9 times 1, which is 9. So what does that work out to be? That works out to be 8 over 3 minus 8 plus 18. That's 12 and 2 over 3. Minus, we work out this side now, which is 1 over 3 minus 2 plus 9. That's 7 and 1/3. So we get minus 7 and 1 over 3. When you work this out, 12 and 2 over 3 minus 7 and 1 over 3. That's 5 and 1 over 3. And I like to write in improper fraction, so I'm going to leave it as 16 over 3. And that's units square. That's the area, 16 over 3 units square. Nice and easy, soft. Part C, and then we'll finish section 3. It says the point P lies on the curve, which has a gradient dy by dx, which is equal to 3x squared minus 6x. And it says find the equation of the curve. So dy by dx is 3x squared minus 6x. So if you want to find the equation of the curve, y is going to be equal to the integral of dy by dx. And so y is the integral of 3x squared minus 6x. All right, that's how you do it. 3x squared minus 6x dx. Now when we integrate, what we're going to get is add 1 to the power, divide by the power. So we get 3x cubed over 3 minus 6x squared. Add 1 to the power 2 over 2. When you integrate, you always put plus a constant k. So that's the equation of the curve y. Now we need to find this constant k, but we know when y is 2, x is 1. So when y is 2, x is 1. So 2 is equal to 1 cube. And you wonder why I didn't put 3, because this 3 cancels this 3, and this 2 goes into itself 1 time. 2 into 6 goes 3 times. So what we end up getting is putting in 1 cube minus 1 square. 1 square is 1, so it's 1 cube minus 1 plus k. Now 1 cube minus 1 is 0, and so k equal 2. If k is equal to 2, then the curve is actually y is equal to x cubed minus 6x plus 2. Nice and easy. And you can check it when x is 1 in this. 1 cubed minus 6 times. Where do I get 6 from? X cubed minus 3x squared. Minus 3x squared. I can check it when x is 1. 1 cubed minus 3 times 1 squared plus 2. Oh, see there, I made an error right here. It shouldn't be plus 2 then. Some error was made. Let's spot that. 3 times 1 is not 1. 3 times 1 is 3. And so we have 1 cubed minus 3. One cubed minus 3, which is 1 minus 3. And 1 minus 3 is negative 2. Then we can carry over the negative 2 to get plus 4. The k is plus 4. All right, so y is equal to x cubed minus 3x squared plus 4. All right, that is it. Nice and easy. Soft. Yep, nice and easy. All right. Just want to check it to make sure it's right. 1 cubed minus 3 times 1 squared plus 4, that's 2. So this is the curve. All right, a nice cubic equation. Now we go to the best module of the paper, which is statistics.